need to invent a commercial.
Right now?
Maybe.
Can I have my keys back?
Alright, one more of this type before I make things a little more exciting. If I give you an expression like that where there are pluses between the terms, can you, this is a square root, can I just divide each of those by 2, break them down separately? Well, no, when there are pluses, you cannot do that. Notice all these ones we had up above here, these were all multiplied variables. There was not pluses in them. You cannot break down individual terms with pluses and minuses. So your only option if you're given something like that is to see if you can get this new factor. So, anybody think of factors that would break this nice little trinomial down? X. Okay, x plus 4 and x plus 4 would do it, wouldn't it? Golly gee, that's x plus 4 times itself. Couldn't I write that as x plus 4 quantity squared?
No, because there's a square root in there.
So what will happen when I have a square root of x plus 4 squared? Yeah, the square root, the square of the 2 will divide into the 2.
So it cancels.
So it cancels and you're down to x plus 4, technically to the first power.
Do we have to write that down?
What did you mean by that?
And x equals what?
Well, you just put your arms up like that.
I don't want to foil. You're setting us up to foil.
No, I'm not setting you up to foil.
It looks like it.
Nope. Do I need an absolute value on this?
Yes, because that's odd.
Yes, why is it an odd? Because this was, this quantity is technically now the first power. I could put parentheses around and say this is to the first power. So, yeah, 2 divided by 2 was 1, so that's the odd power. You have to absolute value that, baby. So, there's your hint of the day for ones like that.
Oh, we got to have absolute values on that too?
Because it's odd. X plus 4 to the first power. So, how many, if you forgot the square root on the absolute value on that, probably a point. On tester's time.
So again, why can't we just absolute value everything?
Because of what I'm about to get to that I haven't got to yet. I'm allowed, I'm surprised nobody has asked me this. We've just done all these problems and you'll notice every time the index divided in there perfectly evenly. Is there a guarantee?
We don't want to ask because we're going to bring it up and then find it on our homework. And
So,
that makes it harder. So we don't
what are
want
we
to
going to do
ask.
if I say what's x, the square root of x to the 7th? Who doesn't divide into 7 evenly?
You divide it and you have remainder. You put it in the decimal form.
Well, kinda. You're going to do division. I'm going to show you the long way why it works, and then you're going to discover the shortcut here. What you have to do is you have to think of, okay, what's the highest power of x that 2 would go into evenly? 6. So you would break this up as x to the 6th times x to the 1st. And you would say, okay, how many times does 2 go into 6? 3. So I would get an x cubed on the outside, and you would be left with a x on the inside then. That's the long way.
I like the idea of dividing it and having a decimal.
There's a shorter way. Okay? We said we were doing 7 divided by 2. Let me take you back to good old basic long division. How many times does 2 go into 7? 3 times. And I would get 6 with a remainder of 1. So 2 went into 7 3 times. I got x cubed over here. I had a remainder of 1, which was the power on the inside of the root. That's x to the 1st. There's the remainder. For the number of times it goes in, that's how many you can take out of the root. The remainder is what's left in the root.
Can you do another one of those?
I certainly can do multiples of that, actually. So, okay, suppose I said let's do the cubed root of a to the 7th, b to the 11th. Okay, how many times does 3 go into 7? 2. You can go in there 2 times, that would be 6. So So that means I can take a squared out, so 3 goes in there twice. What's the remainder? I'd have a remainder of 1 left over, so I leave an a to the first on the inside of the root. Now, how many times does 3 go into 11? 3, that would be 9, so I know I can take out 3. If it went in at 9, that means my remainder is 2, so I have a b squared left inside. Remainder is what's on the inside, how many times it goes in is on the outside. Okay, what I have to worry about absolute values here.
Yes.
Because the A is by itself.
Do I need to worry about absolute values?
On the outside, yes.
Okay. Well, since this was an odd root, can odd roots do you have to keep all odd roots positive? No, we do the cube root of 125 and get -5, and that was okay. You can have negative numbers in cube roots, so if it's an odd root, you don't even have to think about it, there's no absolute value. What about this one up here? 2 went into 7 3 times, you have to absolute value it.
You lost me. I didn't lose you.
Okay, like over here, on the left side here, how are you telling me that these I absolute value this a, I absolute value the y cubed? They came out odd.
Yes.
Okay, but look at what they started with. What kind of an index did you have?
So,
Evens. The indexes were all evens. What were the powers on the inside of the root?
big.
They were all evens as well. We had an a squared and a to the fourth, a y to the sixth. They were all evens. You ended up with an odd power.
So if the index is odd, then you don't have absolute value.
So it's actually what I call the even-odd rule.
That should be what's on your arm.
Excuse me.
I'm sorry.
You need an absolute value if all 3 of those are true. You have to have all 3 parts. You have to have an even index. You have to have an even power when it's inside the root. And it has to be an odd power once you took it outside the root. So look at this one we just did here, this cube root of a to the 7th, b to the 11th. I had an odd power, odd index to start with. So does the even, odd rule work? Did I start with an even index?
No.
Nope, so there's no absolute value. Immediately. No absolute value. If we look at this square root of x to the 7th, it had an even power on the outside, or even index I should say. On the inside of the root it had an odd number. Does that fall into even, odd rule? Nope, so that one doesn't use it either. It's actually fairly rare, you don't use them that often. So let me do one where you'll have to debate it. I can tell you need a challenge.
Yeah.
So that's f to the 21st, g to the 30th, h to the 16th. So first thing, how many times does 4 go into 21? 4 goes into 21 3 times?
Five.
Let's try 5. With a remainder of what?
1.
There would be 1 left over, 1 f left over. Okay? 4 goes into 30. Higher than that. 7 times would be 28, so my remainder is 2. And h, 4 goes into 16.
4.
We need to practice basic arithmetic facts.
Yes.
No, what we need to do is take a nap. The rest of us are tired.
Okay, now, check the even, odd rule. You need to see if you need absolute values. Did you start with an even index?
Yes.
Let me scroll that back up to you. We started with an even index. has to have an even power inside. So which variables had evens on the inside?
G and H.
G and H. So then did either of those turn out odd when we took it out of group?
Yeah.
Just G turned out odd, so only G would get absolute value.
So we have to do the next one.
You look at the original problem, and then what happened when you took it out. So the even had to be on the original, and the odd is when you took it out. Okay. We're good with that? Okay. One more for you here. What if I have you multiply two roots together? Something like that. Okay. Do I break it down first? Should I multiply it together first, then break it down? Break it down first. No, multiply it together first.
Divide it, then break it down.
It's way easier if you multiply it together first. Use your rules of exponents that you just did on the last assignment. Multiply that together and put it in one big root. That's going to be x to the what?
3 to the 4th.
1 and 3 would be x to the 4th. 6 and 4 would be...
24.
Are you adding or multiplying? So it would be 10. Then break it down. So how many times does 4 go into 4? Once exactly, no remainder. So we'll just have an x on the outside. How many times does 4 go into 10? Twice. With a remainder of... 4 goes into 10 twice, that's 8. So the remainder is 2. Okay. Why are you going to lose points if you leave your answer like that?
Because there's a
No
square root of
absolute
square,
value.
so you need to just cross them off.
I haven't checked for absolute value, and I also have something written wrong that's really, really easy to do on these.
Square root of y squared squared.
This is a fourth root.
Yeah.
This has to stay a fourth root. You must remember to copy your indexes down. Otherwise, you're changing your problem. You can't change it magically from a fourth root to a square root. It doesn't work that way.
Sure you can.
You can, but you'd be wrong.
You can. There you go. That's right. You can. Blake is correct. You can change it, but you would be wrong. Now, the question is, did I need any absolute values? And where do I look? If you look right here, after we multiplied it together, you got 4 is, index of 4 is even, both the x to the 4th and y to the 10th were even. Looks like the x came out odd, looks like we should absolutely value it. It would be wrong. Remember I said you have to look at the original problem? Is that the original problem? No. Your original problem was the 2 roots you multiplied. So if you're multiplying, you have to look back at those and go, both indexes had to be even. They were. Then on the x's, were both powers even? Nope. So there's not going to be an absolute value there. Both y's were even. Did they come out odd? They didn't come out odd when we took them out. So do I need an absolute value?
No.
Nope, that one needs none. But you have to look at the original. If it's 2, you have to look back at both of the originals. They both have to be even. So that's why absolute values are actually fairly rare. They don't happen that often. I actually have to plan and work to make you get problems that land that way. But trust me, I will be happy to plan and work to make that happen.
Yay.
What's your plan on?
You got 14.
Okay. M-O-M, okay, well good, we'll just stop and then we'll go graph.
Goodbye.
Imagine another commercial here. Your classmates are singing and dancing about concessions. Imagine people dressed as ellipses, hyperbolas, parabolas, and circles. That'd be great.